So now we're going to talk about a few conditions that occur in lipid metabolism. Now, if I don't know, many of you are in clinical areas and you may have heard of the term ketone bodies. Or you may have heard of the term ketosis or ketoacidosis. You've had some organic chemistry now. You know that they probably involve a ketone functional group. But what does this all have to do with lipid metabolism? All right. In the scenario where someone has been fasting or hasn't been eating enough carbohydrates, you know, all those ridiculous low carb diets, high fat diet, low carbohydrate diet, or in certain diabetic conditions, ketone bodies are produced. Why are these ketone bodies produced? Because there's an excess of acetyl-CoA. So remember, when you've eaten lipids, when you're breaking down fats in your body, what is going on? You're taking that acyl-CoA, you're taking that fatty acid and chopping it up and making a ton of acetyl-CoAs. Well, normally in a healthy body, those acetyl-CoAs, where are they supposed to go? They're supposed to go into the citric acid cycle. But in order for them to go into the citric acid cycle, they need to have oxaloacetate there. So the acetyl-CoA needs to combine with oxaloacetate to make citrate. Okay, if we don't have enough oxaloacetate there, the acetyl-CoA can't go into the citric acid cycle, can't be metabolized, can't get a whole bunch of ATPs. Why wouldn't there be oxaloacetate there? Well, when you've been fasting, you haven't been consuming enough glucose, you're not producing, you're not consuming enough carbohydrate. There's not enough oxaloacetate. So oxaloacetate is dependent on the formation of pyruvate, and pyruvate is dependent on the formation of, on the consumption of glucose. So if you're not consuming enough carbohydrate, then you can't have enough oxaloacetate. And oxaloacetate has to be there for the acetyl-CoA to get into the Krebs cycle. All right, so ketone bodies are produced when there is an excess of acetyl-CoA and an insufficient amount of oxaloacetate. What are these ketone bodies and how do you produce them? Well, because there's no oxaloacetate, the acetyl-CoAs start to combine to form some compounds. And why do they form those compounds? Well, those compounds can nourish your body instead of glucose temporarily. So your brain and your heart can use these ketone bodies instead of glucose. Acetoacetate is one ketone body. Acetone is another ketone body. And beta hydroxybutyrate is another ketone body. Now, this one doesn't have a ketone group in it. It originated as acetoacetate, and then this got reduced. Remember, a ketone can be reduced and produce a secondary alcohol. But these are the three ketone bodies. So when you're in the clinical fields and you're talking about ketone bodies, this is what we're talking about. All right. Now, these are all fine. And when you have them, you have that like fruity smell breath. You could probably smell it. The urine has a different odor too. There's a condition called ketosis, which means you've got too many ketone bodies in your blood. That's not harmful. The harmful one is ketoacidosis. You may have heard of that. Ketoacidosis. Now, notice this, carboxylic acid. Notice this, carboxylic acid. Acetone doesn't have that, but these two. If you have too much of these guys in your blood, you produce too many carboxylic acids. Well, what does an acid do? It reduces the pH of the blood. If you reduce the pH of the blood more than what the buffering capacity of the blood can do, like the buffers in the blood manage to keep the pH you know, what is it, 7.34 or something like that, some place where it has to be. But if you're in this condition because you haven't been eating enough carbohydrates, or you're fasting too long, or you have a diabetic condition where it's your blood sugar hasn't been controlled properly, or you consumed too much insulin and all the glucose went into the cells and your blood glucose levels drop, and you're using your lipids to produce all these ketone bodies. If this happens and you have too much of these guys, they can reduce the pH of the blood, and then you end up with a coma and possibly death. Okay, so that's ketoacidosis. All right, but ketone bodies in and of themselves, not harmful. It's only when you have an excess, and especially of these two, the acetoacetate and the beta hydroxybutyrate. All right, the last thing that we're going to do in lipid metabolism is lipogenesis. Lipogenesis just means synthesis of fatty acids. So what do? Well, the lipogenesis occurs in the cytosol. Remember, beta oxidation occurs in the matrix of the mitochondria. Lipogenesis occurs in the cytosol or cytoplasm. And this is under the big umbrella category of lipid biosynthesis. So if you consume more nutrients than you use up, what's going to happen? You are going to be you're going to be turning all the extra carbohydrate, all of that extra fat into, well, the fat gets stored as fat, but you can, technically speaking, not eat any fat and just eat a ton of carbohydrate and turn all the extra carbohydrate into fatty acids. How do you do that? All those acetyl-CoAs, they start to come together, and 2 carbon units at a time create a fatty acid. So remember, if you've got glucose, let's pretend you're sitting around and you just ate 100 fat-free muffins. Well, yeah, you're not consuming any fat, but all that extra carbohydrate, if you're not moving around, then all that extra carbohydrate doesn't need to go into the Krebs cycle. All those acetyl-CoAs, instead of going into the Krebs cycle to produce a whole bunch of ATP, you're just sitting there. Instead, all those acetyl-CoAs start to combine together to form fatty acids. And this is what lipogenesis is. It's in the cytosol. You don't really have to know all the details. You can read up on it in your book. But what you should know is that there's a carrier called ACP, acyl carrier protein, that transports and carries it, and then the chain starts to elongate on this acyl carrier protein. And I think that's the main thing I wanted you guys to know. And where does this all occur? Mainly in the liver and in the adipose tissue. Adipose tissue is just the fat tissue. The acyl carrier protein just carries things as a malonyl. So acetyl-CoA is used to form malonyl ACP. Again, you can look at the structures in your book. But anyway, the chain just keeps elongating and elongating until you get however many carbons you want in your fatty acid. Your book goes into details of how the difference between making saturated and unsaturated fatty acids. I just want you to know the general idea of this, and I think that'll be enough for this section here. Okay, good.